All right, so we've done the inductive reasoning, the warm-up. Yes, sir? So you're going to have a lot of definitions in geometry, so you need to be prepared for that. My test quizzes, they have definitions on them. You need to make sure you could match them. You don't have to say them verbatim. So you need to match them and understand what they mean. If you read the word, you need to know what it means and how to solve for it. Conjecture in math is an educated guess. Does anybody know another word for it in science class?
Hypothesis.
Hypothesis, okay. The hypothesis in math means something completely different, so beware of that. On your test, you're going to have those definitions, and sometimes you can get them confused with the science and the math meaning. So conjecture is meaning an educated guess. All right, what we're going to be dealing with in this first section is inductive reasoning. It's finding a pattern. Like you're looking at those first letters of the words and trying to find a pattern. Making a prediction. So if I look outside and I say, every time I see a dark cloud, I think it's going to what?
Rain.
Rain. Okay? You said storm. Something like that. Now, how did I come up with that? How did I come up with that conclusion? That guess? Experience. Very good. All right? By experience. I know when it gets dark, it's going to rain. Does it always rain? No. So my guess can be sometimes wrong, right? It works for the most part, but not always. So not the best way, not the best conjecture, but sometimes it does work. My goal is to come up with the conjectures that always work, okay? Now sometimes you'll have conjectures that you need to find a counterexample, all right? That means it's an example that shows it's false. So by experience, we've seen it be dark outside, right? Dark clouds, but it never rained. So that would be an example, a counterexample, an example when it's false. I only need one example of when it's false. So let's try this practice. Example 1. I've got 3 patterns of a triangle, ABC. What would the next pattern look like? There would be one. What would it look like? What would be to the left? The A. So you're saying that if I took my picture and I rotated it, it would look like that? So everybody agree? You're right. Very good. So that's what your next pattern will look like. The A started at the top, then it moved to the right, moved to the bottom, moved to the left. So it pretty much rotated 90 degrees, right? Each time. Any questions? All right, example 2. It says predict the next number. So tell me what the next number should be and tell what the pattern of the sequence is. So what's happening as the pattern goes on? Okay, so you see it's going down. And if it's going down, it's usually, not always, usually either subtraction or division, right? Somebody tell me subtraction. What's happening between the 17 and the 15? Minus 2. What's happening between the 15 and the 12? And the 12 and the 8? So what do you think is going to happen next?
5.
And the next number would be?
3.
Okay, so that's my next number. Now let's explain this pattern. Anybody tell me what's happening in the pattern?
Subtract by more than the last one, by 1 number.
Good. Your wording can be different as long as you're having the same meaning. He said you're subtracting 1 more from the previous number. That's fine. Okay, my word was, subtracting by the next incrementing number. It does not matter. You could say going down by the next number. I'm not particular about the wording as long as I know what it means. And you've got to make sure you're clear and that it works in order for me to accept it. And I'm using the number symbol for number. All right. right, so example 2, part B, what's happening here? Is it going up or is it increasing or decreasing? Decreasing. And usually if it's decreasing, you've got a couple of options. You've got subtraction and division, and the harder one to see is like square roots, cube roots, and things like that. But what's happening here? You say it's division, and what makes you think that it's division? Good, because you have fractions down here, probably means that you're dividing, and it's going down. So can anybody tell me how much you're dividing by? You're dividing by 3 is what he says. Now, how did you get that?
16 over 3.
Good, because he said the 16 over 3 right here, that's the difference between the one that's previous, right? Well, check it out. How about 48 divided by 3? 16 divided by 3? 16 thirds divided by 3? 16 ninths. How about 16 ninths divided by 3? You're right. It's 16 twelfths. Does anybody remember that rule? If you have 16 ninths divided by 3, you know what you really are doing? You're taking your fraction and you're multiplying by the algebra. Do you remember that? Multiplying by the reciprocal. Very good. So 16 ninths times, what's the opposite of 3? What's the reciprocal of 3? 1 over 3. Remember, flip the fraction? And that's where you get your 16 times 1 and 9 times 3, which is not 12, it's 27. 16/27. Make sure you correct that because I didn't catch. Thanks. All right. So on C, you think it's a square root? What makes you think that? Okay, 7 times 7 is 49. Very good. And 49 times 49 is 2,401. So you went from backwards. Did you see how you thought that up? How you figured it out? You started from the last number given. And 7 times 7 is 49. Let's check. 49 times 49 is that. Well, what's another word for 7 times 7? 7 what? Squared, right? And how do you get rid of a square? Do y'all remember that from? You take the square root. So if I take the square root of 2,401, I get 49. I take the square root of 49, I get
3.
Okay, the square root of 7 does give me a decimal, which is very good. All right, I don't want the decimal. I want it in the simplified radical form. And if you haven't done simplified radical form in algebra, we'll figure it out. You would have to do a little factor tree if you did that. What are factors of 7? 7 and 1. So it is simplified. So my answer, the next number would be the square root of 7. Please don't give me the decimal of it. Keep it as a square root of 7. That's the answer. Now what happened? What was the pattern?
You gave the square root of each number.
Good. So you take the square root of the previous number, right?
Yes.
Okay. So D, 2.1, 2.01, 2.001. Can anybody tell me what my next number would be? So you said 2.0001. So that would be my next answer, and you're correct. All right, now what did we do? We added 0, but where?
In the 10th position.
In the 10th position. You can multiply, but you have to be careful. Or depending. So you said you add a 0. And very good. You were very specific to the tenth, which is the one place after the decimal with the TH. That's how you know it's after the decimal. Is that good? Question? No? All right, example 3. There's this game called Rummy Cube. If you've never played it, it's just a tall game with numbers and like a couple of smiley faces that are wobbling. And in Rummy Cube, when I'm playing the game, I can find the sum of 3 consecutive numbers very quickly. And I'm not adding the numbers in my head, okay? There's something that I'm doing. There's a pattern. I want you to make a conjecture based on the pattern you observe. In other words, dealing with 3 consecutive numbers. Something happens all the time that I can do, and I can add up those 3 numbers very quickly to find out what the answer is. Give them just a second to think through it. If you think you know the answer, just hold on just for a few minutes, and when I ask, I want you to think through it. 3 consecutive numbers. I'm not adding them up, but I can find the sum very quickly in my head. So let me give you a couple other examples. If I did 4 plus 5 plus 6, I know that the sum is 15. Didn't add them. Six plus 7 plus 8 is 21. Didn't add them. And this works with any 3 consecutive numbers. They think they know the pattern? I've got one. I'm going to call somebody over here because I don't think you're thinking of it. You look. Look at that last one. 10, 11, 12, 33 automatically. How many numbers do we have in each group? 3. Something to do with 3. Are you sure? You want to try? Okay. And you thought? And you thought? Anybody think something different? You take the middle number and you multiply by 3. Does it work? 2 times 3 gives me 6. 6 times 3 gives me 18. 11 times 3 gives me 33. 5 times 3 gives me 15. 7 times 3 gives me 21. Can anybody think of one that doesn't do that? Okay.
I just gave for 33 when I gave 12 when I'm supposed to gave
And that's the same kind of concept. Yes, you're right there. He said, well, he took 1 away from 12 and gave it to 10 and made them all 3 11. It's the same kind of concept. 2 times 3 gives me 6. Well, if all these are 11, 11 times 3, because you get 3 11s, is 33. And that's the concept. That's where it comes from, and that's why it works. But you're right. Take the middle term. And multiply by 3. So very good. So good? A little bit easier? Realize anytime you have to do three numbers added quickly together that are side by side, the very next number, you know, always take the middle one, multiply by 3. It's easy, it's quick, and you don't have to add. All right. I want to show conjecture is false. So anytime it wants me to show something is false, I've got to find a counter example, an example that makes it false. So let's look to see what the conjecture is. They say the difference of two positive numbers is always positive. Okay, so I want to come up with something that makes that false. So what am I looking for? I'm talking about the difference. What's difference? Subtraction. All right, so that means subtract. Difference means subtract. So I need to know that information. Difference means subtract. What's two positive numbers? Numbers of what? 1 and greater, right? Any numbers, but I still need positive numbers. 2 of them. Okay, wait. But instead of being positive, I want to make it what? Negative or neutral, which is 0. So this is what I want to change. I want to make this part false. Everything else has to stay the same. Okay, I got to deal with difference of two numbers, making it not positive. And you said try what numbers? 1 minus 2. 1 minus 2 gives me negative 1. That's a counterexample. I could be finished. My little equal sign's kind of messed up. But 1 minus 2 equals negative 1. What's another one? 1 minus 1, which gives me 0. Those are counterexamples. Are there more than one of those? Yeah, there's tons, but I only need one. Okay? So if you and your neighbor get something different, that's fine. That's great. Any questions about a counterexample? That term, you need to know what it is. Counterexample, an example that makes it false. Any questions on that section? All right. We're going to move on to 1.2. The warm-up we're going to do together on this one. All right, so this is the XY standard form coordinate plane. Okay, if you don't remember what that is from algebra, it's your X coordinate first, comma, then your Y, close your parentheses around it. If you don't write it like that, it is incorrect. Okay, it's got to have parentheses, it's got to have the X, comma, the Y. So, A, where is A located? What coordinates? What? You said it's what? 4. So 1, 2, 3, 4. This is the x-axis if you don't remember, and that's the y. So A is located at 4, what? 3. Very good. It's a little harder to see on this board. A lot of times you're going to see it numbered, like they'll see a 5 here, so it's a little easier to see. So what's B? Negative 4. B is at negative 4, positive 1. We're on B, sorry. Anybody have questions on that? Remember that from algebra, some of you? All right. So we're dealing with points, lines, and planes. This is very, very important. The way that we name it, we'll be naming things, pictures, objects, shapes for the rest of the year. And the way that you name it has to be correct. If you name it incorrectly, I will count it wrong. Okay, the first test has a bunch of ways to name it. You're going to have to name them. If you miss one little thing, it's wrong. So beware. You're going to be tested on definitions. Make sure you understand it. Undefined terms are points, lines, or planes, since they can only be explained by examples or descriptions, but you will be defining them or matching them. All right, a point. The point has no size. All right, you have to name it by capital letters. Here's your key point. If I see a point right here and it's got the letter A beside it, when I name it, I can just put A. That's beautiful. let's go over here. A. If I have more than 1 point, I'm going to put a comma between it. If I don't have a comma, I'm going to think that you're naming two different or one thing. Then the next point. B, capital A. Make sure I can read your writing. If I can't read it, I have to count it wrong. A line. A line goes forever. Okay? You with me? Forever. Because it's got arrows. Thank you for noticing. He says they've got arrows. So if you're drawing me a line, make sure you have arrows on the ends, both ends. A line is made up of at least 2 points. Okay? Any two, they call them unique because they're not the same point. So any 2 points I draw, I can make a straight line going through them, right? All right. So you need to know that a line is made up of 2 points. Any 2 points. It can be more than 2, but any 2 points. They go in both directions, never ending. You can name them with a lowercase letter if given. So right here I could name it line L, and I actually want to use the word line, cursive, whatever cursive letter it gives you. It's a lowercase cursive letter. All right, it'll be at one of the end points or one of the little arrows. You can name it line, that. You can name it by the 2 points, any 2 points, right? But you have to have a line over it. Now, what kind of line? With straight line with arrows, right? Very good. So you can name it that way. You can name it backwards. Now, I like AB better, but that's just me. But this is also true. All right, if it has 3 points, okay, if there was a C here, point C, all right, I still could name it AC and it'd be the exact same line. You with me? But I only name it by how many points? 2, thank you. I only name a line by 2 points. There could be 5 points on that line, but I only name it by 2, any 2. And you could use the word line AB, line B to A. I don't really care. This just saves you time. This is the one that I would use, and if I preferred to, because it's shorter. All right, a plane. A plane is very hard to describe. A lot of times we'll say the floor is a plane. However, a floor ends, right? A plane never does. You just have to realize that. The plane keeps on going in all 4 directions forever. However, because it's hard to describe, we can only do it by picture, we say things that end, have segments on it. Now when I draw a plane, you want to make sure you have arrows going off in all directions. These lines tell you that they keep going in all directions. We just can't show it. A plane has to have 3 points. Okay, 3 points non-collinear. Do you remember what non-collinear means? All right. Non-collinear means lines not on the same line. So non, right? And then co-linear. You see the word line in it? Okay, co means with, and non means the opposite of, right? So not on or not with the same line. 3 points not on the same line. Okay? 3 non-collinear points. Beautiful. Well, you know what? A line, you can make any 2 points, right? But as long as 3 of them are not on the same line. Okay? So as long as B's off to the side or one of them, I can make a line going through AB as long as C doesn't go in that same line. Okay. So any 3 points. Okay? What's your confusion?
But you said they don't supposed to intersect with their intersection.
No, I never said the 3 points don't intersect. Okay, are you talking about the lines on the edge here? Okay, that just represents that they keep going. So like this side's going to keep going this way. This side's going to keep going down. This side's going to keep going to the actual planes can intersect. So they can intersect. Eventually we'll talk about that. But it's just that those lines represent that it keeps on going in all directions.
Okay.
All right. You can name a plane if it's given with an uppercase letter in one of the corners. Okay, so I can name it by, and I would have to use the word plane. Got me? You're going to have to use that word plane, the capital letter, or I can use the word plane. I know it's going to happen. The plane and the 3 points on it. I can use any 3 points. So if there's 5 points, guess how many points I'm going to use? 3. Any of those 3. It's tricky. If there was a D in here, I don't care. I'm still going to name it ABC. If there's an E in here, doesn't matter. It's still the same plane. Okay? Any 3 points. Now, here's the deal. It can get kind of overwhelming according to how big your picture is. Try to name them in alphabetical order. That way everybody's will be the same, and when I grade them, I don't mess yours up. That's just for my benefit. But you can name them by any 3 points. But for my benefit, if you can, I'll try to look. If you do it in alphabetical order, I don't make mistakes. And a lot of times the picture, the more involved it gets, the harder it is to grade. Any questions? What word do you have to use with plane when you name them? The word plane. Got it? You have to have the word plane in there. If you have more than one, put planes, and then I'll take it. Okay? Make sure you separate them out by commas if you have more than one. Collinear. Remember the word line is inside collinear? So colline, on the same line. It could be whatever points they name. If they say name 4 points, name 4 collinear points, you're going to give me 4 points that are on the same line. If it says name 2 points that are collinear, give me 2 points that are on the same line. Read your directions very carefully. Non-collinear, this is the tricky one. Non-collinear. If it says name 3 points that are non-collinear, 2 of them can be on the same line. However, the third one can't. All right? If they say 4 non-collinear points, 3 of them can be on the same line, as long as that 4th one's not. You got me? It's a tricky one. Did I lose you? So if I have 3 points on the same line, but this one's over here, I got to name all those 4 points. Did I lose you? Maybe. Got a picture like this, and named it A, B, C, D. They say name 4 non-collinear points. Well, I can choose A, B, C. There's 3 collinear ones, right? But the 4th one can't be on the same line. D. We'll do some examples. Coplanar. What word is almost in there? Almost. Plane. It's missing an E. Okay, so it's kind of like collinear. But guess what? Coplanar means what? Don't leap. Yeah, on the plane. So points on the same plane. Again, read how many points we're talking about. Non-coplanar, not on the same plane. Good. Remember how many ever they say. If they say name 3 non-coplanar points, 2 of the points can be on the same plane as long as the third one's not. Lots of definitions of geometry. Bear with me. Don't tune me out. You're going to have them. They're going to be on your test. Array has a starting point, which is called the initial point. That will be on your definition. All right? And it goes in one direction. So you have a starting point, and it goes in one direction. Now, your ray can start over here and go to the left. It's harder for us to imagine, but it does. Or it can start to the left and go to the right or up, down. It doesn't matter. The key point is when you name it, you've got to name it by its starting point. So if this is AB, Guess what? When I name it, it's got to be what?
BA.
BA. Very good. And then what goes above it? You can put a dot and then an arrow. I don't care if you put a dot here. That's fine, if that helps you. All right? So BA, your arrow, when you name it, always has to be pointing to the right. Okay? I can't name it like this. That would be incorrect. Okay? That is incorrect. It's got to be your starting point first, then another point on the ray. Any other point on the ray. Delusia, you still with me? Naming is huge, so make sure you're with me today. Okay, a line segment has a beginning and an ending point, an initial and an end. Endpoints is on your test also. Okay. When you name it, it doesn't matter if I go, let's look at the picture. If I go BL with a line segment above it, if you put 2 periods on the end, that's fine. Or if you name it LB. All right, either one of them is correct. Now you could write it out, line segment BL or line segment LB, but the symbols are a little quicker. Okay. When you read a word problem, either look at the symbols or read the words very carefully because it may say line segment. Well, then you know how to draw it. You know what you're dealing with. It may say line, so be careful. Okay, another term called opposite rays are 2 rays going in opposite directions to make a 90-degree angle. So I've got a ray AB and a ray AC. Guys, there's only one A. Are you with me? When you have 2 rays and they have the same letter in it, they're connected. You got me? They're connected. That's only one A. There's a ray AC and a ray AB. It's beautiful writing. 2 rays, 1 letter A. Okay, that A has to be connected. Opposite rays go in opposite directions. They create a 180-degree angle. All right, that's a 180-degree angle. So anytime you hear about an opposite rays, you know you have a 180-degree angle. Intersecting, when lines intersect, they intersect at 1 point. When planes intersect, they create a line. Lines intersect, they intersect at 1 point. Remember, planes keep going forever? All right. When 2 planes intersect, they intersect at a line. Yes.
You always have the arrow going that way.
On a ray, yes. On a ray, the arrow has to always go to your right, point to your right. All right, these are postulates, things that help you answer questions are accepted to be true. So we talked about it. Any 2 points determine a unique line. That means 2 points make a line. You got me? Any 2 points can make a line. All right, 2 distinct lines intersect, and their intersection is a point. When 2 lines intersect, they intersect at a point. That's what it means. Line L, line M intersected. They intersected at point P. All right? We're not in the book yet, so just wait on. 3 non-collinear points determine a unique plane. Means any 3 points that are not on the same line make a plane. Guys, if I'm dealing with a shape, a solid, all right, and I'm calling the points where the planes intersect, okay, these are points. This is a plane right here. Remember, we can't describe a plane because we don't actually have anything that keeps on going forever and ever in real life. But we do have objects that we can pretend are planes. Like this surface, flat surface right here would be a plane. Okay? And there's several planes that intersect, and if we're pretending they go on and on forever, they intersect at well, this is a line segment, but if it was really a plane, it would be a line because it keeps going forever, right? All right. And that's what's on the next page. All right, so an example. Name 2 points on the line. How would I name them?
DA.
2 points on the line. Somebody? How would you name it? Nope, I'm naming points. Points are made up of B, capital B. What's another one? A, capital A. 2 points on the line. You have to name them. You can do A, B, I don't really care. But you have to name them capital letter, comma between them. Okay, give 3 names for the line. I think that's what you were naming. Give me 3 names for the line. Line D. All right, another?
Line A.
Nope. AB, and how's it look? With a line on top with arrows. All right, what's another? Same way? With a line on top and arrows? Okay, you could also name it, I don't really care, line AB. All right, any of those are correct. Again, this would be the one that I would choose just because it's quicker and it's alphabetical. Questions? All right, let's do another. Name 3 points that are collinear. Collinear means what? On the same line, very good. So 3 points that are on the same line. M, P, Q, and how do I separate them out? How do I know there's 3 different points? Commas, very good. All right, now I'm looking for 3 non-collinear points. But N and M are on the same line. She's right. She said N, M, and P. And that's correct. All right, as long as one of them is not on the same line. N and M are on the same line. M and P are on the same line. But all 3 points are not. Does that help a little bit more clear on the non-collinear? All right, now you could have more. I could do N, P, Q, right? There's lots. All right, either one of those are fine. All right, good. Name 3 segments and 1 array. Whew, segments. Segments have what? Okay, hold on for that. Segments have what?
At least 2 points.
At least 2 points, and what do we know about the points? There's something very specific about a segment. They don't go on forever, so their end points, at least their 2 points have to be on the end. Now you're going to answer it, so what was yours? For the segment. Okay. Not quite. Not D, E, F, but a segment is named by how many points? 2. So what's your?
DF.
DF is a segment. And you've got to have a line above it. Somebody else want to give me another one? DE is a segment. Somebody come up with another one? EG is not a segment because they're not straight across. They have to be straight. FG. EF is also one. Okay, but we only needed 3. 1 array. You said what? What about GF? Good. So she said FG has to be it because F is the end point. Okay, F is the end point. Very good. Any questions about those? Y'all are rocking. Doing great. All right. Here's another. Now remember, when we start dealing with 3D objects and you're looking at them on your books, they're going to be a little harder to see. So be aware of that. There's my cube. We're naming all the planes that are represented in the prism. Now when I name a plane, I have to have what word? Plane. Now remember I said if you have more than one, you can write planes out and then put commas between them, and I will take it. Now how many letters do you name a plane by? 3. There's 4 though in this plane. Do we care? No. I just need 3 of them. All right. So let's do the top. This top piece right here. Name it for me. ABF is fine. All right. If you did it AB, we'll have to go to the very next side. So that'd be F. Okay. Next one. We did the top. So he's doing BFE is the same plane. CDH, we got the bottom down here. CDH. Now, if you're naming them separate, remember, don't forget the word plane, but because we've already named it, it's okay. CDH. So we got the top and the bottom. Whoa, I heard it back here. One. Give me one. FHG. That's the front. And I would have taken EFH. That's the same thing. So that's the front. ACG is the side. Okay, so we have 2 more. We have the back and the other side. DCG, we've already got the bottom. BFH, that'll work. And we need the back. What? Oh yeah, ABD. Very good. All right, anytime you're dealing with a cube shape, a box shape, you're going to have 6 sides. That helps you a lot. So if you don't have 6 and you name it out, what I do, especially if you're not drawing in your book, don't draw in your book, but if I have it on a sheet of paper, I will trace it. But please don't draw in your book. If you do, make sure you erase it. All right, example 6, name the intersection of a plane. Okay, we've got 2 planes and they intersect. What do they form? 2 planes when they intersect, they form a what? The intersection is what shape, what thing? When 2 lines intersect, they intersect at a what? A point, right? So if 2 planes intersect, they intersect at a what? A line. So we know that our answer is going to be a line. Now let's look. A, B, C. So this plane right here and plane DEF. DEF. This plane right here. They intersect. And you know their intersection is going to be a line. So you said what? H is the last point. It's a little hard to see in your notes. H is back here, this back point back here. DA or AD. And it's a line, so how do I represent a line? Either write the word line or put a line with arrows above it. Very good. You see how definitions can overwhelm you? A lot of definitions in geometry. On the test, they're going to use those definitions to describe things. And if you don't memorize what those are, you're going to be having hard trouble to do a problem that may be, simple. Any questions? We're done with notes today. You okay?